This is an Airbus 380 and it can weigh at takeoff 560 tons. Incredible, isn't it? But then, how does a plane fly? In this video, we'll provide the briefest and simplest explanation of how it works. Welcome to a new installment of World of Aviation. I'm Marcos. To grasp how an airplane flies, one must first understand some key concepts. Don't worry if you don't understand initially. I will explain the same thing multiple times in different ways, repeating to ensure the concepts are very clear. Newton's first law says that if an object is static, it will remain static. Like this apple on top of the table. It doesn't move because the forces are balanced. And if an object is in motion, it will stay in motion unless another force intervenes. But what does this have to do with airplanes? Well, they stay in the air, in static flight, because the different forces acting on it balance each other out. The force of gravity pulls down towards the center of the Earth, offset by the lift force, which we will see how it is produced. The air passing through creates lift, which is balanced by the engine's thrust that also generates resistance to progress. But then, how do we achieve the so important lift for airplanes to fly? A fundamental part here is the wing. It has a special profile that when it moves through a fluid like air, it generates a pressure difference. Less pressure on the extrados or the top part of the wing and more pressure underneath it or intrados. And this pressure difference generates a force that we call lift. And to understand this, we need another concept, the Bernoulli principle, which tells us that if we have an airflow, that is molecules that are moving, these separate from each other, causing their pressure to decrease. This concept is crucial to understanding how planes fly, so we'll make it more complex. Technically, the Bernoulli principle postulates that there is a relationship between the speed of a fluid and its pressure, and that the energy of a flow is always constant. Let's see. What does this mean? So, if the pressure increases, the speed decreases, and vice versa. What interests us is that if the speed increases, the pressure decreases. This means that if I manage to make the air pass faster over the top of an object and the bottom part remains at a lower speed, an upward force is created, the lift. This explains why strong winds can rip the roof off a house as we see in this video. When I was a child, I used to do this experiment, which you can also do at home, with a strip of paper or a cloth tape. If we blow above this strip of paper, it lifts up. This is because I'm accelerating the airflow above the object, creating a force to lift it. To explain Bernoulli's theorem, this graph is usually shown. Here is where the fluid comes with a certain speed, and when it passes through the narrowest section, its speed increases, decreasing its pressure. There is less pressure in this place than in this one. I'm going to leave in the video description the link to this page so you can play around changing these variables. In the last experiment, I will use these two empty cans and something that serves as a small tube to direct the airflow. What do you think would happen if I blow through these two cans? Maybe some of you think that nothing will happen or they will separate. But if you paid attention to Mr. Bernoulli, again, if I speed up the air, its pressure decreases, and as the surrounding pressure is stronger, a force is generated that brings the cans closer. So if I manage to make an object with some shape, make the air pass over it faster than below, lift is achieved, and this shape is the airfoil profile. And now we are getting closer to understanding how a plane flies, because in the airfoil profile, due to its special shape, the air on its upper part has to travel a longer path than on the lower part, but in the same amount of time. That is, the air above has more speed, and therefore, I've already told you many times you should know less pressure than below, generating the lift force. As I said at the beginning, I always need that thrust force provided by the engines to generate the necessary speed so that the flow is fast enough to produce that lift. Do you remember the four forces? If any of them varies, its state will change. For example, if I decrease the power of the engines or the thrust force is somewhat weaker, the airspeed will decrease and therefore the lift will decrease, causing the entire plane to descend. There's also the issue of the angle of attack, but as at this height you are already experts in air pressure, it will be very easy to understand. All planes used to fly with almost flat wings. They had just a slight curvature to mimic bird wings, but in angle, just look at this plane. Here, when the profile is at an angle with respect to the fluid, the pressure is due to the fact that below there are more molecules colliding than above the wing, so to speak, thus generating the pressure difference. In fact, the fan you have at home works on this principle. As a child, I enjoyed sticking my hand out of the car and feeling it move up and down based on the angle due to this phenomenon. So, a plane flies because of a set of these principles. But how does a helicopter fly? Well, we can consider that the blades of its rotor are like wings, but they rotate to generate the necessary speed for lift, but we will see this in another video. It should also be said that airfoil profiles are in everything that wants to generate a force, such as propellers, parachutes or paragliders, and even the blades of a wind generator. I hope it was understood and you liked it. If so, don't forget to like and comment, that helps a lot when spreading the video. Remember that there are donation methods, PayPal and Patreon, if you want to contribute financially to improve the channel. Thank you very much for watching, until a new delivery. My name is Marcos and this is World of Aviation. Thank you.